Welcome back to another Ramda JS video. It's pretty late here, so I have to be quick and quiet. But of course, today it's gonna be quick because we're gonna talk about the function f, and we're also actually gonna talk about the function t. But f stands for false and t stands for true. And as you can see here, when we read the description, you can see that it's gonna be difficult for me to sort of go on too many sidetracks, and I'm gonna try not to go on sidetracks today. But the description here of the definition of the function is essentially this. F is a function that always returns false. Any passed-in parameters are ignored. And then they're saying see also t, and if we check out the description for t, you can see that t is a function that always returns true. So any passed-in parameters are ignored, right? And then see also f. So it's f and t, true and false, but they're not constants, right? They're not variables. They're not the same thing as true. They are functions that when given any arguments, so you can actually think of them as nullary functions, right? Functions that you just invoke, and then they return either true or false. And if we read the type definition here for f, you can see that when given any parameter, so the star here, which could have been an a, right? But when given anything, it returns a boolean. So it returns either true or false. And in this case, it happens to return false. And if you look at true, it's the same type definition. Given given any value, it's going to simply return a boolean. Of course, I guess maybe the reason that they put star instead of a is probably that since, I mean, as usual, JavaScript is variadic, so you can pass any number of arguments that you want, but it's going to ignore all of them and simply return the corresponding boolean anyways. So let's just try this out, right? Let's jump into node. Let's say const r is equal to require Ramda, so that we load in Ramda, and then you can see we have R.T and we have R.f as functions. And interestingly, or I mean, let's just start with f and let's just try this out, right? So like if we run R.f on hello, we get false, right? If we just invoke it by passing nothing, we get false. If we pass 1, 2, 3, 4, blah, 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 bunch of arguments, right, we still get false. If we take those numbers and we pass them in an array, it doesn't matter. Like it blindly doesn't care about what we pass it just returns false. And what's interesting is, let's say that we wanted to define our own function f. So let me define a variable that I just call capital F. Then what R.f actually is that it is the constant function. So it's function passed to the constant function, and the constant function in Ramda is R.always. So R.always is ran on the value false. That would be the same thing, right? So if I now call f on foo, I get back false, right? And remember, always you can define sort of like this. I'll call it k because I would like to call it const, right? As short for constant, but in JavaScript, const is a keyword, so we can't use const as an identifier for a function. But then k is also commonly used because of SKI calculus. Let me just Google this, calculus. We've looked at this before, I believe. Yeah, SKI combinator calculus. So k is commonly then used for. Let's just zoom in here. K is then commonly used for the constant function. So if k is applied to x and then to y, then it will return x, which is exactly what we have here. Like if R.always is k and we apply it to false, then it doesn't matter what we apply it to next, and we'll just simply get back false. So we could define k ourselves as well. In other words, we could define the function R.always ourselves by simply saying that, well, first you pass some x, then you pass some y, and then you'll return the x. So now we're doing it in a sort of explicitly curried fashion. We're taking not multiple arguments, but we're returning a function that expects the next argument rather than just taking two arguments. So then if you run k on foo and then you pass bar, we'll get back foo, right? And so same thing, if we then say k false, that means that we have a new function that completely disregards whatever we pass it after that, because if we pass something else, we'll still get back the first value, which was false. So we'll always get back false, essentially. And so then we can redefine our function f to not use any Ramda functions, but simply use our own definition of false. So or our own definition of k. Sorry. So f is then equal to k applied to false, right? And now we can again still use our f function to say, well, if you pass whatever, right, you still get back false. It doesn't matter what you pass it, you always get back false. And so I would guess maybe that's actually the way they've implemented it. So let's look at that. If we jump to the source code of Ramda, let's see. No, of course, I mean, sorry, again, that was silly of me to assume that they implement it that way, because again, as we've talked about before, their job as a library is, of course, to also provide not just the functions that are useful, but functions that are fast and useful, right? So functions that are as performant as possible. So they're optimizing for, or I assume that they are optimizing not exclusively, but like quite extensively for performance rather than for readability, or for, let's say, reusability, or for like composing different things, which makes sense, right? I mean, what we did now when we said that f is the application of k to false, like, or the constant function to the value false, that's sort of merely a theoretical exercise that we can do when we are writing a program if we don't necessarily care about performance, or if we want to define something on the fly by using partial application. But if you're writing something that is to be reused by others, or if performance is important, then you should probably just like build a strict implementation, because of course we can also redefine f like this. Like we can say that f is a function that when passed some x simply returns false, right? Like that's also a simpler definition of the false function. I guess the interesting, or of the false function, I guess we should call it the false function. And of course, conventionally, maybe we should do like this. We should say that we should name the variable underscore to emphasize that we really don't care about this argument, right? We're just taking an argument for the sake of it being a function. Actually, maybe I can do this. Can we do this syntactically? Yeah. So we can do that. So then if we invoke f, we now get false back. Ooh. Yeah, okay, that works. Yeah, so in JavaScript, idiomatically, I assume this would be a more idiomatic way of expressing that function. Maybe. I don't know. I would also say that it makes sense to use this sort of underscore syntax, but whatever. So yeah, that's false, right? That's the false function. And same thing for true. I mean, I don't really think we have to talk about true, because it's, I mean, you can probably see that it's very trivial. Like it's exactly the same thing, but instead of returning false, they return true, right? They're defining a function t, or they're defining a variable t, which is a function, or which contains a function that simply returns true when you invoke it, right? And then they export that function. Same thing as for false, but for true, right? And same thing, we could just say let t is equal to, let's say, k of true. Like it's the constant function applied to the value true, and then we store that in the variable t, right? Or we call that function t. So if I invoke that, now we get back true. And so the question you might ask yourself is, why would you use this, right? And I'm actually struggling to come up with sort of a good example. So I think I'll just allude to this idea that in some video way back, I think we talked about if-else. Wait, oh, we are at f. So confused. I'm like, are we already at t? Yeah, so we haven't talked about... Yeah, I don't think we've talked about if-else, but I think we have talked about... No, but then we haven't talked about identity either. Aha, interesting. Okay, maybe I've sort of alluded to identity, and you've probably come across identity as well. At least in my introduction to Ramda video, I think I talked about identity, right? So the identity function, I guess that's also part of a SKI calculus, right? Yeah, I, right? So I, in SKI calculus, which is sort of a theoretical exercise in regards to functions. This is, I don't really know. Yeah, I don't know a whole lot about that, but those are some pretty interesting functions, right? So I is the identity function, k is the constant function, and s is a substitution operator. That's a bit more complex, and we've talked about it in other videos, but it doesn't matter for this particular video. But so the identity function, there is an identity function in Ramda, and that is essentially R.identity. And the thing with identity is that whatever you pass it, you get that same thing back. So if we pass x to identity, we get x back. If we pass 1, 2, 3, we get 1, 2, 3 back. If we pass true, we get true back. If we pass, let's say, a function, let's say we pass r.add, which is a function, then we get that function back. Like you just simply get back the same thing. The reason I'm saying that is that there's also the function if-else. And if-else has this syntax. Let's just look at that. I didn't really think about the fact that we hadn't talked about these yet, so I'll just sort of skim over them, and then we'll talk about those in detail when we get to them. But so if-else, notice the type signature here. It's taking one argument here, one argument here, one argument here, and then it returns a function. So if-else is sort of a function that produces a function. And what you do is that you pass it a condition function. I think I must have talked about this before. And then a truth function, and then a false function. So then the value will be passed into the condition function. And if the condition function yields a truthy value, then then that same value, the original value, will be passed through the truth function. And if the condition, or I should say, but if the condition yields a falsy value, then that original value will be passed through the falsy value. And again, the reason we get back a function here in the end is, of course, then because when we're passing the function to if else, and then like when we're passing the condition function to if else, and then we get back a function, and then we pass the truth function to that function, we get back a function, and then we pass the false function, and we get back a function, and that's the function that expects a value. And when we then pass a value to that, we get either, let's say, this value here, like the result of running something through the truth function, or this thing here, which is the result of running that value through the false function. And of course, I guess the reason for these parentheses is mainly also because they want to support variadic functions, right? So your condition function might actually be a variadic function, which is fairly interesting, and I think we should look at that when we are at if else. But for now, let's just, what I wanted to say is that I think R.identity makes sense when you look at it in the context of if-else. If you ever used, I mean, of course, you've probably used Excel, but I mean, if you used formulas in Excel, at some point you might have used the if-else logic, and then you might have come across this, let's say, need for identity. I can't actually remember if they have identity in that, but yeah, okay, sorry, but then we don't think about it in terms of functions. But then, I mean, it's fairly sort of the same thing, where it's like you can say, well, if-else, if this condition is true, then I want this cell, but otherwise I want the same cell. Or, yeah, I'm not making a whole lot of sense now. Yeah, let me not think about that. I just vividly remember that when I first thought about if-else in the context of identity, it was also in a discussion with a friend. I sort of strongly thought about Excel, and I thought, okay, this is exactly what I've been doing in Excel. Sort of like that. But yeah, I can't it's too late. I can't map my head together. But anyways, the point with identity, what I'm trying to say is that maybe you have a value, and if, let's say, the condition is true, like if the value ran through the condition produces something which is falsy, maybe you want to transform that value in some sense. But if it produces something which is truthy, then you maybe simply want to return that value, right? So let's say that I have, now actually I'm going to pass the false function here, just to simplify things for me. So let's say that the condition is that we don't care about what the value is, but we just return false. Actually, maybe I should do this. Maybe I should say, let's actually do this. Let's assume that we have a valid function, right? Or let's say is valid that takes some x and then returns something, right? Checks whether that x is valid. But we're just going to say that is valid is equal to the false function, so that every value is false. And then we say, okay, r dot if else, if is valid, then what are we going to do? What's our truth function? Well, truth function is maybe, then let's just return the value. Then here's the value, right? Good stuff. Maybe it's like a user validation. But if it's not, then maybe we return, let's say, the constant. So I'm going to use R.always, the constant error, the string, or let's say not valid, right? I mean, this is an arbitrary, sort of an arbitrary, my words. It's sort of fictive, right? What is that word? It's not arbitrary. It's sort of contrived, right? The example is sort of contrived, but I think I hope you see my point, right? So let's say so if that other function is valid, then maybe we should call this function validate, right? So we'll save that into validate, and then if we pass validate, and then we pass, let's say, Chris, right? It's like let's say we're validating a username, right? So then I get back not valid. Actually, maybe a better definition is this. Let me now remove let, so that, because we've already defined the variable. Instead of not valid, let's say Anonymous. Is that the spelling? I guess that's the spelling. Yeah, let's stick with that. So maybe we're validating a username, and to be safe, what we do is that if the user has provided an invalid username, then we simply like immediately just turn that username into the string anonymous. So now if we pass Chris into validate, then we get anonymous, right? Because now we've said that the validation function is false. Let's now change is valid to something like, I don't know, like does it do we have something like contains in Ramda? So maybe we should, yeah, but that's for list. But like a substring or okay, hang on, I have to let the cat in. I just want to figure out something that we could do, that we could just trivially check here. Okay, sorry. Actually, there's index of or something like that, right? So in the last, yeah, index of. No, but this is actually an array. Init index by find index. Yeah, let's not think about this now. I mean, there should definitely be a function here for that. Okay, so maybe this is when we should look at, so instead of me just hand waving this away, what is that called? Like the Ramda cookbook? So this is actually a great resource. Yep, here, what function should I use? So then, sorry, my cat is really in the way, so I can't see anything. Cat, please. Okay, here, so then you can see, okay, well, our type is not a list, our type is not an object, it's not a function. What? I guess we should have a string here somewhere. What? Sorry, the cat really wants to hang around. Did I miss? But maybe actually, I mean, it's possible that most of the list functions are actually support strings. So maybe I should just try that, right? Like let's say contains. Whoops, contains. We were looking at that. That takes a list, and then let's say, what if we say R contains foo if we have the string foo bar? Whoops. Yeah. Okay. Does it contain foos? Nope. Sorry, hang on. So sometimes they're really determined to hang out, and then you can't ignore them. Like it's not allowed. So okay. So contains actually works on strings. So that was my bad. But this is a quick sidetrack, right? What I want to do is just something like this. Like let's say we've define is valid as whether it contains, or like let's say the R not of. Whoops. Oi. No. Is valid is. Let's say R dot contains, and then maybe, I don't know, let's say we can't have slashes, okay? And then I guess we do something like this. We pipe, so we'll say pipe, first contains, and then R dot not. I guess that would make sense, right? Because then if we say is valid Chris, then that should be valid. But if we say Chris, Chris slash, then that's false, right? Maybe I could have used a regex or whatever, but doesn't matter. So now, because we mutated the variable, we should have changed the validate function. So if I now try to validate Chris, we get, oh no, sorry, okay, I didn't actually change it. So validate, we're running if else on valid, and I either get, if it's valid, then I get back identity, and if it's not valid, then we'll get the constant anonymous. So if I now try to validate Chris, I'll get Chris, exactly. And if I try to validate Chris /, then I'll get anonymous, right? So this is a long sidetrack. What I wanted to say is just this sort of, I wanted to bring this up sort of as a parallel, right? Because let's just go back to f here, right? Because we have the functions f and t, and I think f and t are sort of trivial in the same sense that identity are trivial. That most of the time you'll just think that, well, I would never sort of need this thing, but actually sometimes you need them, because many times let's say, let's put it this way. I mean, we've talked before about the function either, and we've talked about the function or. And the interesting thing is that or works on values, while either works on functions that produce values. And it just seems to me that either is just a terribly more useful function than or, because if you have something that works on functions, it's much easier to reuse that, because you can sort of just put that into a context and easily change it by sort of altering the functions that you pass to that particular thing. But however, then I assume that sometimes you end up in scenarios where you don't want the function, and then you could simply use some of these trivial things such as identity and maybe f and t. But really, I can't really spontaneously figure out any scenarios for when I would use f and t, unless of course I'm again, like, let's say I have this, like I've already written this validate function, but let's say, yeah, I don't even know, right? It's like maybe validate. Yeah, I mean, it's like maybe so validate is, our validate function is maybe a bit too simple. But if it was something like validate was defined such that it takes a function which is the validation function, and then maybe you could pass f or t here, right? So again, like if you have these, you have an already existing if else, and you don't want to change that if else because that's logical in that place. But for some reason in this particular invocation of that if else, you want to sort of force the computation to go the true path or the false path, and then we could use f or t. But yeah, those are just some thoughts on how or why you would use that. I guess also from some sort of category theory sense, it would make more sense to have, or maybe like a functional programming sense. Now I'm totally guessing, I'm on super deep water, right? But I would guess it makes more sense to have a function that produces a value rather than a simple value. Because then you, like if you have a pure language and you have functions that produce values, then I guess in some sense you never actually have to think about the actual values, because a function under some particular input that produces some particular output is equivalent to that value. But now I'm in, yeah, let's not finish this thought. I will go and let the cat in, and then I will leave us both with that confusion, and let's try to figure out whether that kind of makes sense or not. It just spontaneously feels like a function that produces a value is a sort of more superior, is a superior construct in functional programming rather than just a value. But maybe I'm just being stupid now. Anyways, I'm glad to have you along. This was another Ramda JS video. Remember to subscribe, and I'll see you in the next one. Thanks for watching.